So I'm going to be talking about securing agents without defeating their purpose. Kind of similar to what Alexi was talking about, but from the other perspective of wanting to get value out of using agents or delivering agents, but how to do that securely. So first, I'm going to say a bit about me. I'm at OSO. We do real-time enforcement of deterministic logic. So when you click around in an app like Brex, Vanta, ZoomInfo, 1Password, their backend is doing a real-time call to OSO for everything that you do and we determine whether or not you're allowed to do it. And they enforce that basically. And so what we're currently kind of working on is helping our customers adopt agents safely. And I'll say a bit about why this is kind of a hard problem. You might be aware of like maybe your CISO is kind of scared of people using agents within the company. So I'm going to speak a bit about what kind of dynamics are going on there. So, in this talk, I'm going to talk about how safety is kind of the main problem that we're seeing blocking agent adoption at various companies, and how simple solutions throw the baby out with the bathwater, and what kinds of solutions people are kind of doing that are a bit kind of heavy-handed and not allowing you to get the full value out of your agents being agentic. And then I'm going to talk about how sequence-based enforcement, I'll explain what that means. Sequence-based enforcement helps secure agents without defeating the purpose. So the kind of landscape of where agent adoption is today is that agents like Claude can do extremely powerful things, especially recently. Kind of everyone across the industry is seeing how incredibly valuable it is to be using agents like Claude. And I mean, there are other things like OpenClaw, recently acquired by OpenAI. I think the whole industry, the whole world is kind of waking up to like how powerful agents are. But there's a big blocker to actually using agents to do real work, and the blocker is the lack of safety guarantees. Even if Claude often behaves correct, there's not often a guarantee that it's not going to do something absurd, especially if you have sensitive DLP situations, meaning like you can't be leaking customer data to the public, or you can't be dropping a production database like we've seen like so many news stories about. So the kinds of problems, like some notable examples of agent safety problems. Very recently, this article came out about how AWS Kiro caused a 13-hour AWS outage after deciding to delete and recreate the environment, which there was a different story about that happening with a different agent last summer. It's funny that's an AWS outage, though. And then Notion AI, this is a different kind of vulnerability. If you are applying to a job at a company that uses Notion and you embed some like invisible text in your resume that has a prompt injection, then Notion's AI can see that text and then exfiltrate your internal Notion documents. You can tell it to basically read some other documents and then go and encode that information in a URL. And then you call the web search tool. It does a request to that URL and includes a query param that has your sensitive information in it. And so that's like a sequence of events that can happen that allows attackers to exfiltrate information. So that's one example. And then OpenClaw is kind of like classic. Like everyone talks about how cool OpenClaw is, but nobody talks about like, I want to use OpenClaw like on my laptop. It's always like, I want to run it on a MacBook Mini that I'm like hidden in the closet and not letting it touch the internet or anything. It's like a scary thing to be running OpenClaw, and we're still figuring out kind of how to do that effectively. So this is kind of representative of the problem with agents and agents being powerful. And it's kind of hard to guard against these kinds of problems without defeating the purpose of agents. So I'll show like a demo example of like a particular vulnerability, and then we're going to kind of iterate through ways to solve that, some of the ways that people are currently solving that, and then what we think is kind of a better solution to solving that that doesn't completely throw the baby out with the bathwater. So the demo example is a lawyer managing emails, kind of a classic example of something that's kind of tricky. It'd be cool if, as a lawyer, you could use an agent to do email correspondence. You are dealing with a lot of like coordinating scheduling for meetings. You're dealing with following up on emails that people haven't responded to, but also like you have attorney-client privilege, and you can't be taking information from one email and then emailing it to someone else. So I'll show like an example of that. Just gonna swap my sharing. Um, all right, so I'm going to mic stand anywhere. All right, going to with one hand type Claude. And I'm going to ask Claude, what is, so let's pretend I'm a lawyer and one of my clients is named Gabe. What is the most recent email I sent Gabe? And so I have a Gmail MCP hooked up to my Claude. It's going to call the MCP, get the email. Wow, that's some pretty heavy stuff. I hope the opposing counsel doesn't find out that if they invoke Article 1, Section 2.3, then they win the lawsuit. Better not leak that information over to them. And so, just for like demo purposes, you can imagine multiple reasons how this could get leaked just by having this MCP hooked up to an agent. Claude is a particularly good agent. If you did the same thing in OpenClaw, like somebody can send you an email with a prompt injection and then just tell OpenClaw to like send you an email with other information in it. So, I mean, lawyers can't really be using OpenClaw in that state. But there's no guarantees, even in an agent like Claude. Hallucinations can still happen no matter how good quality the models are. And on top of that, you can yeah, you can have prompt injections, you can have hallucinations, and fundamentally it's just like a non-deterministic thing, and there's no real guarantees. So it'd be kind of hard to convince yourself to hook an agent up to a Gmail inbox without any guarantees like that. So let's say the opposing counsel is someone named Ash, and I'm going to ask him to send an email. And the reason, I mean, this is kind of a dumb example. I'm just telling it to do it, but you can imagine various ways this could happen. And then I'm going to show kind of how we can guard against this while still not completely killing my ability as a lawyer to like use an agent to manage my emails. So that actually emailed Ash. So I've told him to ignore his email from me for the next few hours. Anyway, let's go back to the presentation. All right, so what are the solutions to this kind of problem? And I'm like, first of all, why is it hard to build a solution to this problem? So this is an analogy called throwing the baby out with the bathwater. I did some research on this. When you give a baby a bath, you often want to discard the bathwater, but the baby is of value, so you don't want to discard the baby. So in this analogy, the baby is like the capability and autonomy that you get out of agents, whereas over permissioning you can think of this as an over-permissioning problem. And most of the news stories that have come out, it is described as an over-permissioning problem. You want to get rid of the agent having the ability to do things that it shouldn't be doing, but you don't want to completely defeat the purpose of an agent, which is like to do things. So some heavy-handed ways to lock this down is turn off the send email tool. Like obviously that'll fix the problem. If it can just read emails and not send emails, then like yeah, you're not going to be leaking data, but um like then you can't use the agent to do a lot of stuff. You can't follow up on like people not replying to your emails. You can't be like coordinating scheduling a time to meet with someone about something. You can't like send information from other MCPs that don't contain sensitive client information. Some people just stop it here though. They just say like, I'm going to give all my agents in the company read access to everything. And I'm going to write a AI security policy that doesn't allow any sort of write access, doesn't allow any tools that can change the state of the world. And that's the AI security policy because anything else is too scary. We feel like what we're seeing in those situations is you're not really getting the productivity boosts out of agents that you're really supposed to be getting. And so we're looking for how to enable people to get the kind of value out of agents that you want to without kind of making the agent what we call them impotent agents. So um, another example of how you could fix this, human in the loop approval. So this is a really common one. Claude does this by default. A lot of people look at this problem and say, I want to allow the agent to do slightly riskier things. Solution, just always ask the human to approve whether or not the action should be taken. How many of you have like asked Claude to do something complex and then like you tab away and you're like doing something else and you go back and you expect it did a bunch of work and then you realize it like stopped asking you like, hey, is it okay if I read GitHub documentation? And it just didn't do anything after that. So there's that problem. Fundamentally, though, if you even if you are like watching the session and hitting approve, if you want to do something that kind of like really leverages the value of like agents being to able to do things at scale, if you have like 100 clients and you want to like send follow-up emails to all of them, or you have a lot of like unread emails and you want to send follow-up emails to all of them, at some point when you're hitting approve on every single tool call, you're not really thinking about it that hard. So we don't really think that's very secure. Rather than human in the loop, we like to call that human is the loop. And it's both tiring and you stop paying attention and it's not very secure. So one other solution is, this is kind of a silly one, but you could choose, like, I don't want to not have the ability to send emails. I don't want to not have the ability to read emails. What if I just choose when I start the session whether I'm going to send emails or read emails? Obviously, that's kind of silly because you can't like read an email and see that it hasn't been responded to and then ask them like to follow up on it. So splitting this apart in this way kind of gets in the right direction of like you are no longer completely locking out the ability to send emails, but it's still not quite there. This is much closer where you can maybe read as many emails as you want to. You can maybe send emails if you want to, but once you have read an email, that email could contain sensitive client information. Now the entire agent's context window is tainted. No matter what happens at that point, any of the subsequent messages could, in theory, contain sensitive client information. So after that point, you can't send an email. Still not quite there because like you still can't read an email, see that they haven't responded to it, and then send a follow-up email. So here's where this kind of like sequence-based authorization comes into play. Um, this is based on a field of computer science called information flow control. What you can do is you can view the specific recipients on an email, and this concept kind of generalizes beyond email, but the specific recipients of an email can be kind of the guardrail that you narrow your permissions to from that point on. So as soon as you've read an email, you can allow the agent to send emails after that point, but don't allow it to send emails to people outside that participants list. And this is not logic that we expect you to like think about for every single tool and every single like agent. That's kind of our job to kind of bake in like what the narrowing of scope is. And so I'm going to show you an example of this happening. So I actually have OSO hooked up to this Claude session, and I intentionally turned off some OSO guardrails here. So I turned off that demo fact, and now I'm going to ask you to do this again. So we got a tool use denial. This is a kind of a demo example where we're hooking in as a Claude hook. We typically integrate at the network level because it allows us to do the same kind of enforcement across all agents, not just Claude, and also doesn't make it as easy for employees to opt out of if this is something that the security team wants to kind of apply across the org via something like a SASE or a ZTNA. So that's the example of not sending it to Ash. And then let's try to send it to Gabe. And we're able to send it to Gabe because the only email we have read so far is one to Gabe. And so we're not leaking information across clients in this way. So this is actually configured. It's customizable. This is configured with a purpose-built authorization language that we built in-house for low latency enforcement of complex policies. Uh, this is a lot of comments, and you don't need to like read all of this right now, but just know that this is customizable. And our goal for securing like coding agents and vibe coding is for us to write the policy kind of for you and apply it in a way that works for the popular MCPs. But if you have more custom use cases or applying in-house MCPs to your agents as well, you can kind of extend the policy as you would like. So back to the presentation. Yep. Oh, that was not it. That's my talk. Thank you.